These two images were generated using the Q5K GGUF version of the latest heavyweight model Qwen Image 2512 on a laptop with just 8 GB of VRAM. The Q5KM version is a massive 15 GB. If you have a laptop with 8 GB of VRAM, you can run this model and generate an unlimited number of stunning images, completely free right on your machine. This is fully uncensored. I have attached the JSON file with the full workflow and direct download links in the description and comments below. Here's the model page on Hugging Face. You can see all the models here. The smallest Q2 model is 7.2 GB, the Q4KM is 13 GB, the Q5KM version is 15 GB. Here you can see the text encoders. I'm using the UD Q5 GGUF version, and you should also download the recommended MMP ROJ 16 Next. We have the Qwen Image 2512 Lightning LoRa model. Finally, here's the VAE model. Here I have created a download models group for you, and all the models will be directly downloaded to your downloads folder once you click the links. You can also see exactly where you should put your downloaded models. Open your ComfyUI folder and then the subfolder models. Drop the Qwen Image GGUF model inside the unit folder, the two text encoders in the text encoders folder, the Lightning 4 steps LoRa model inside the LoRa's folder, and finally the VAE safe tensors file in the VAE folder. Now, this is very important. Always keep your ComfyUI up to date to prevent all sorts of errors and frustrations. If you have any missing nodes, just click the Install Missing Custom Nodes option here. Here you can see the nodes where you select your downloaded models. Select the main Qwen Image 2512 GGUF model in the GGUF unit loader, the text encoder in the GGUF clip loader, the VAE in the load VAE node, and finally the LoRa model in the LoRa loader model only node. That's it. Now you are good to go and unleash your creativity. Here you can see my specs on TechPower GPU Z and the task manager. Now let's click the run button to generate our first image. Check the system RAM. It spikes right up to the 31.5 GB mark. So you absolutely need at least 32 GB of system RAM alongside your VRAM because you have some heavy offloading to handle. Now it has been reduced and is steady at 18 GB. Here you can see the prompt I'm using. This is a simple yet complex prompt that tests the model's abilities. Here is the negative prompt I'm using for this one. As you can see here, the VRAM usage has stabilized at 7.1 GB and the system RAM is around 17 GB. Remember, we are using a 15 GB model here. Here in the command prompt, you can see how much data has been offloaded to the system RAM. Around 8.5 GB have been offloaded, and that's the reason this process takes a bit longer. That's the price we, the laptop and 8 GB users, have to pay. Here you can see the settings used for this generation in the K-sampler. Control after generate has been set to fixed since we are going to compare some models in this video. And here's our image. It's absolutely stunning. It has stayed true to our prompt. Here in the task manager, you can see the system RAM usage is sitting at 23 GB. The models have been loaded into the system RAM. So the next generation is going to be faster. It took 210 seconds to generate this. Now let's set the scheduler to beta. Beta has given me better results than the simple option, so the difference isn't always massive. Here you can again see all the details in real time. You can see the steps are set to 8 instead of 4, even though we are using a Lightning 4 steps LoRa. That's because 8 steps gave me significantly better results, especially when using complex prompts. Check out the process again. It's really smooth. I'm running Chrome and OBS Studio in the background, so you can safely browse the internet, watch a video or complete a project while this is being generated without worrying about running out of RAM. Now here's the second image. It took 155 seconds since all the models were already loaded. 2.5 minutes for an image is still a lot, but this is a 15 GB heavyweight model that can push the boundaries. This is honestly an achievement for us laptop users. We are getting almost the same results as heavy server grade GPUs. Now, let's check generating the same image with the Q4KM model. It's around 12.5 gigabytes. This is a new model we are using, so it's going to take a bit longer than the previous one. I've been experimenting with this model for 2 days now, and I have batch generated a lot of images and got really great results. Be sure to use a good cooling pad and you are good to go. Here's the image using the Q4KM version, and it took 180 seconds this time. Now, let's do a side-by-side comparison. Here are the images we generated in the Configure output folder. On the left side, you can see the image generated using the Q5KM model, and on the right side, the image generated using the Q4KM model. Well, as you can see, it's really difficult to find a difference between these models using these specific images. Now, let's try the same prompt using the Q2 model. Here you can see only around 2.5 GB has been offloaded to the system RAM when using the Q2 model. Now, here's the image. It took around 155 seconds and it's such a mess. If you want to download this just because it's only around 6.7 GB, please don't. Now let's change the model back to Q5KM and try generating a complex comic book page. Here is the complex prompt we are going to use to generate the comic book page. As you can see here, a lot of adjectives and meticulous instructions are included in the prompt. Here's the negative prompt for this one. Around 8.5 GB has been offloaded to the system RAM again, since we are using the Q5KM version for this one. The process is again really stable, as you can see here. And here's the image. It took 205 seconds because we previously unloaded the model and then loaded it again. Otherwise, it usually takes around 160 seconds. And that's it, guys. You can perfectly run the Q5 or Q4 model on your laptops with 8 GB without any issues, only if you have 32 GB of system RAM. Please tell me about your results in the comments below. See you in the next video.